Hello, welcome to the first lecture on scientific notation. We're going to break scientific notation down into two parts. The first part is going to be covering the basics on what is scientific notation and how do we write numbers in that format. And the second part then will be how do we use scientific notation in calculations with our calculator. So a really brief tutorial on how do we use these in our calculators. Okay, so you guys have already heard of scientific notation in some form or another, and this cartoon illustrates that. So here we have a girl that is saying, I just won 3.6 million in the lottery. And then the mother there is responding, do you realize you just used scientific notation? Okay, so we all know that we can take a number like 3.6 million. And if you had to turn that into a number form, you would say, oh, I can do that. That's 3,600,000. That's 3.6 million. In other words, it's 3.6, and then, after the 3 here, there are 6 places. 1, 2, 3, 4, 5, 6. Scientific notation is exactly the same thing. We just write it a little differently. I'll show you how we write this number with scientific notation, and then we'll go back on how I did that. So we would write that as 3.6 times 10 to the 6. This would be that number in scientific notation. Okay, so this is 3.6, and then I have to move the decimal place 6 spaces. Okay, so let's just back up a step, and we'll go over some basics here. So this slide, if you look at the PowerPoint, illustrates what scientific notation is used for and what the format is, and it's going to always be the same. Okay, so very useful for writing numbers, say greater than 100 or smaller than 0.001. It's much more efficient. It saves us writing all those zeros and avoids, maybe making mistakes, with counting how many zeros or where the commas go. Okay, so the key components to scientific notation, let's just use this number as an example. Okay, the first part will always be a number between 1 and 9.999. Okay? So in other words, there will only be a single digit to start with, and then you can have a decimal with as many places as you need. So this can be 1.000 or 9.999, but this first number can never be 10, and it can never be 0. So never 10, never 0, because then there would be 2 digits or no digits before there. Okay? The second part is going to always be the same, times 10, always the same. Okay? So when we're writing numbers in scientific notation, it'll always be some number times 10, and then the final component will always be the power that 10 is raised to. This will always be an integer, and it can be positive or negative. Okay? So it can be a positive or negative, and that will indicate whether the number is really big or really small. Okay? So a positive number will make it a really big number. A negative number will make it a really small number. Okay? And we'll demonstrate that by going through some examples. That will help make it a little bit more clear on how we do this. Okay? So again, on the slide here, you can see they have a number 6.022 times 10 to the 23rd. And so that means that that's times 10 to the 23rd power. Okay? Now, let's take a look at some examples and see if we can learn by example. Okay, so the first example we have here is to write 1023 in scientific notation. Scientific notation. Okay, so the way we do that is to think about where's the decimal place right now, and where do we have to move it to get a number between 1 and 10. Okay? Right now, the decimal place is right here after the 3. Okay? I'm going to need to move that decimal 3 places to get a number between 1 and 10. So if I move that decimal place over, you can see right now that number will become 1.023. Okay? So I moved the decimal to make this number be a number between 1 and 10. Now to continue writing in scientific notation, I have to add the times 10 afterwards. Okay. Now we have to figure out what power we want to raise it to. Well, the power we want to raise it to, since this is a big number, I want to move my decimal place back over here. So I would need to move it 3 places. So this is going to be times 10 to the 3rd power, and that's going to be positive. Okay? When we have a positive power here, that means we move the decimal to the right 3 places, and that would give us 1023. What this means mathematically, 10 cubed is equal to 1000. That's 10 cubed. 10 times 10 times 10 is 1000. So what this number right here is telling us is it's 1.023 times 1000, which would equal 1023. Okay, so mathematically, we're just doing a mathematical operation here, 1.023 times 10 to the 3rd. That will equal 1023. And that's how we write scientific notation. Okay? Big numbers, numbers greater than 1, will always have a positive power here. Okay? Let's take a look at a small number, a number less than 1. A number less than 1, our second example here, 0.00235. Okay? So again, now we identify, where's the decimal? The decimal point is right there. Now we move that decimal 1, 2, 3 places to get a number between 1 and 10. So that's always the key first step in taking a number and moving it into scientific notation. 3 places. So now the number will be 2.35. That's the number between 1 and 10. And this second part, always the same, times 10. Now we have to figure out the power. Again, I moved the decimal 3 places, but this time I moved the decimal, in this case, to the right to get to my number between 1 and 10. So in this case, I'm going to want to move the decimal to the left to get it into the number form. If I want to move the decimal to the left, this power has to be negative. So this is going to be to the negative 3rd. So when this number is a negative, again, we always move that to the left. So this would be this number in scientific notation. Again, what that means mathematically is 2.35 times 10 to the minus 3rd power, which is 0.001. If you take 10 to the minus 3rd power, that's what you get. So we move this over 1, 2, 3 places, 0.00235. So this number in scientific notation is the same as where we started from. Okay? So that's how we write small numbers. Small numbers will always have the negative. Big numbers will always have the positive integers. Okay? And that's in the bullet points that are on the slide. Okay? Let's work some practice problems. So what I'd like you to do right now is to pause the video, work out these problems, and then I'll go through each one, and we'll see if we can get the right answer. And again, now in these problems, we're going to have to go both directions. Take the number, go into scientific notation, or take the number in scientific notation and go into the decimal number, the regular number. Okay? Pause the video and give these a shot. Okay, I'm going to work through these one at a time. If you get one wrong, I would suggest pausing the video, seeing if you can figure out what you did wrong, and then going and checking the work on the rest of them. Okay, so the first one, 2,130 is the number. We want to write that in scientific notation. So again, identify where the decimal is. Right now, the decimal is right there. To get to a number between 1 and 10, I have to move that decimal place over there. So my number between 1 and 10 would be 2.13. Okay? There's my number between 1 and 10. We have to add the times 10. And now we have to think about, I moved the decimal 1, 2, 3 places. So this power is going to be 3. Now let's just double check whether it should be positive or negative. In this case, I want to move the decimal to the right to make it a big number. If I want to move it to the right, that's going to always be positive. So this is the correct answer for number 1. Okay, let's take a look at number 2. Number 2 says 7.4 times 10 to the minus 4th. Okay, in this case, we have a number in scientific notation. They want us to go into decimal form, the regular form of the number. Okay. So now we think, oh, okay, 7.4, I'm going to do this in 2 steps. 7.4 is our number that we're starting with. I need to move the decimal 4 places, because that's the power of the 4, but it's negative. That means this number has to be small, less than 1. So I'm going to move this decimal over 4 places. 1, 2, 3, 4. The decimal is going to move right there. 1, 2, 3, 4. That means I'm going to need to insert 3 zeros before that decimal. So my final answer will be 0.00074. That would be the answer to that question. Okay, again, we can go backwards to get to a number between 1 and 10. 1, 2, 3, 4 spaces. Minus 4 because it's a small number. Okay, next one, 9.8 times 10 to the 6th. Okay, we want to write that in number form because it's in scientific notation. So again, I'm going to start with 9.8. Okay. Now we're going to move that decimal. How many places? 6. 6 places, and now we have to think, do I want to move it to the left or to the right? Since this is positive, this has to turn into a big number, so I'm going to move it to the right. I'm going to move it to the right 6 places. 1, 2, 3, 4, 5, 6. There's where my decimal is going to go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And then there's the decimal. Sorry, I was a little high. Decimal. So my answer, final answer, will be 9,800,000 or 9.8 million, just like in that first slide example that we had. All right, last one. Okay, last one, we have this number that's really small. 1, 2, 3, 4, 5, 6. Count to make sure. 1, 2, 3, 4, 5, 6, 7 zeros. And then a 5, 6, 7. Okay, so that is a really good example of a very small number. This would take up a lot of space if we had to write this. Scientific notation is a way more efficient way to write a number like this. 1, 2, 3, 4, 5, 6, 7, 8 spaces to get there to a number between 1 and 10. So my number between 1 and 10 will be 5.67 times 10 raised to the 8th power. Again, we need to think very carefully, positive or negative. In this case, I want to move the decimal to the left to make it a small number, so that's going to be to the minus 8 power. So that would be that decimal represented in scientific notation, the minus 8. Let me review these. Oh, I don't have them revealed there, but let's go on to another set of practice problems. Okay. Now I want you, again, pause the video, see if you can work through these, and then we'll go ahead and reveal the answers and see how you did. I'll work through each one quickly. If you get them right, great. If not, go back and rework them. Make sure you understand, or write down what you don't understand and bring that question to lecture so I can help you with it. Okay, so first one, the number is 490. I wanted to write that in scientific notation. The number between 1 and 10 would be 4.9 times 10. 2 places I would have to move that, so that would be 4.9 times 10 to the 2nd, and that would be positive because it's a number greater than 1. It's greater than 10. Next one, 3.75 times 10 to the minus 2. Okay? Minus 2 means that it's a small number. I have to move my decimal place to the left 2 digits. 1, 2. So that's going to give me 1 0 before the 3. 0.0375. 2 places to get there, and it's negative because it's a small number less than 1. Okay. 0.3 zeros, 0, 0, 0, 5, 9, 5. Again, 1, 2, 3, 4 places to get there. 5.95 is my decimal that's between my number between 1 and 10. Times 10, always the same. 1, 2, 3, 4. 1, 2, 3, 4. 4 places. Again, this is a small number. 4, it's less than 1, so that needs to be negative. So I know now when I go back to a regular number, I move to the left. Let's make some space and do the last 3. Last 3. Well, actually, there's 4. 9.46 times 10 to the third. 9.46 times 10 to the third. Again, change this into a number. I'm going to take 9.46. I'm going to move that decimal place to the right 3 places because that's positive. 1, 2, 3. 9,406. 3 places. 1, 2, 3. Okay. 38.7. And this is a number we wouldn't necessarily turn into scientific notation because it's easy enough to write, but we can still do it. So as a good illustration on how to do this, number between 1 and 10, we would just have to move it 1 place. 3.87 is the number between 1 and 10 times 10. Now I just move the decimal 1 place. If I move it 1 place, that's going to be raised to the first power. Or in other words, 3.87 times 10 is 38.7. All right. 7.10 times 10 to the 6th. And 6 here, that's our million factor. So again, this is 7.1 million. So again, we're going to move that decimal place to the right 6 places because that's positive. We want to make this a big number. 7,100,000. 1, 2, 3, 4, 5, 6. We'll put that right between the 7 and the 1. Okay. And our final one, 0.000, 4 zeros, 82. And we're going to move that decimal so it's the decimals between the 8 and the 2. So we have a number between 1 and 10. 1, 2, 3, 4, 5. 8.2 times 10 to the 5th. But again, we have to think this is a really small number. If I want to move this decimal to the left to get back to my decimal form, I need to indicate that with a -5 there. Okay, so that's the answer to those questions. And if you have any problems or you don't understand something, go back and rewatch. Use your textbook. There's also a couple great resources I can recommend. So the pages in your textbook are pages 14 and 15. Take a look at that, and there's some practice problems there to work. There's also a great instructional video at the Khan Academy. And if you download this PowerPoint, you should be able to click on that link. Otherwise, just go to the Khan Academy and search for scientific notation. Finally, there's some couple really good YouTube videos, both with explanations and practice problems. So Tyler DeWitt has a great series on lots of basic chemistry principles. Go to YouTube, you can search for Tyler DeWitt Scientific Notation, again, or click on those links if you download the PDFs. Okay, great. Next up will be part 2 on how do we enter these numbers in our calculator.